a lesson on activity 4. And so let me go ahead and cite in some things you're going to need to know. We're on page 902, but I have to use the graphic from the previous page. So I have this graphic handy for you in the rest of the calculations. I also have one of the yellow calculators, and so you should have your yellow calculator handy. If you do this with any other device, that's fine. Desmos is amazing, but I want to make sure that I'm also promoting using that calculator to do our calculations. There's a lot going to go on in this lesson. And so in order to be able to handle it gracefully, let's talk about it. The probability of landing anywhere in the section labeled 20. So as a reminder, bringing this to our screen, the section labeled 20 is the wedge in this area. And so if you land in the 20 section, it's at least 20 points. Could be double, could be triple, but we don't care about that. All that we care about is the section labeled 20. What is the number of points for that amount? Okay, so our setup. We have the outer ring. It's the circular scoring area, and R is the radius of the outer ring, and then we have the inner radius. And the reason for that is when we're shooting or throwing a dart at the board, if you land in the bullseye, you've won. So this little corner wedge right here, we're going to take this circle away from the actual outer one. And then last of all, I guess, why do you think we're dividing by 20? Because in that formula, there is an area of a circle formula involved, but dividing by 20, why would that be? I mean, it's possible that you can score from 1 to 2 to 3 to 4 to 5 to 6. You can score up to 20 points at any point. So this entire dartboard circle is actually broken up into 20 slices. So this labeled 20 number is just that slice, but you take your total area, which is what the top is going to calculate for you, and you divide by 20 because there are 20 slices. So let's do this now. Notice, let me move me over here. Notice that from the center out to the edge, that's 6.7 inches in radius. So the capital R amount is the center all the way out to the outer edge of the scoring area of 6.7, and then we square it because it's, pi r squared. Then we're going to subtract the inner circle, and there's an inner radius, so we're going to take away from the outer circle the inner section, and then last of all, we divide that by 20 so that we can get the slice of this dartboard that represents the score of 20, but it's just, one of 20 different arrangements. This is where the calculator has to happen. So we have, let me move a little bit of my windows around. Okay, so you're over there. You're looking over there, right? Go over on that side of the screen. We have Control Divide. Oh, oops, I'm sorry. I need to press the Quick Graph button. So this is a quick graph right here. Now, Control Divide will set up the fraction. Then we do r squared, but that's so I need to do pi. Sorry, I'm backing up. I need to do pi. Now I'm looking at my formula, and I'm looking at my calculator, and I typed the pi button. At any point, by the way, you can go back and you can rewatch, okay? Parentheses, 6.7 squared subtracted by 0.625 inner circle inches squared, and then down to the denominator to type a 20. This already has decimals being used, so our answer is going to be in decimal format. We have an approximate area of the scoring 20 section of 6.99. How accurate? They want to be super accurate. 98. Oh yeah, it is 99. 6.98. So then if it goes 995, I'll do that accuracy because the calculator said it. Okay, now the dartboard itself, reminder, the dartboard itself is, where did I get the 247? I got the 247 on the previous page. So the entire diameter of all of the circular surface of the board is 17.75. So if you divide that diameter by 2, you wind up having the radius, and the formula for area of a circle is pi times radius squared. So I'll calculate that here, but I'll use that number every point on from this point on, that's the total area of our circle. So again, it's pi, parentheses, and then I want to do the fraction. Although I could just use division without the fraction, it looks nicer when what I type matches what I wrote. That is 17.5 over, so I'm going to go down to the bottom of the fraction, over 2. Go outside. I pressed the right button twice to move my cursor to the outside edge, this way, right? The outside edge of the parentheses, and now I'm going to hit the square button and enter. 247.45, these are square inches. 247.45 square inches. Okay, then the geometry is done, so the probability of landing in the section labeled 20 is going to be the fraction of landing in the 20 out of the total. 6.98995 divided by 247.45. So I can use my yellow calculator easily enough. I don't delete any of the calculations. I just press the up button until I go up to the number that I want to use. Then I push enter, then I push divide, then I go up and I push enter, and now I press enter one more time. I have a 0.0282 chance. It's not nice as a percentage, so if I right now go times 100, I have a 2.82% chance of landing in the 20s. Not bad. It's not amazing, but it certainly should feel somewhat acceptable that you're going to throw a dart and the odds of actually landing in that space, just, winging it, is pretty low. The probability of landing within the outer ring, but not the inner ring of the bullseye. Let's go to the next question, right? Here's it in its entirety. The probability of landing within the outer ring, but not the inner ring of the bullseye. So picture-wise, our outer ring is all of this green, red, green, red, green, red. And then the inner ring is what's here on the inside. So the way that the question is worded, where it says they're probably landing within the outer ring, it's like we're landing in the donut of outer versus inner, and it wraps around. So we need to find the area of the outer ring, pi r squared, and find the area of the inner ring, pi r squared, and just subtract them. That's what's set up in the problem here. So I have the calculator. Bring it up. Here we go. Calculator. And just to confirm it, by the way, so bringing up the picture as well, it is 0.625 for the outer ring. That is this green. I drew the circle too big. And then the inner ring is just the bullseye, right? That's this language right here, radius of the inner ring from the previous page, radius of the outer ring. So our calculation is going to be the area of the green subtracted by the area of the red. Calculator. If you want to keep all of those files, you can, but it is nice to have a fresh screen. So I'm going to go menu 1, 5. And if I didn't like that, I could go Control Z like on a computer and it would all come back. Or I can do Control Y and send it away again. Outer ring area. That would be pi r squared. And pi r squared times, so pi times 0.625 squared. Will that work? It did. It put it in parentheses. I was kind of worried that I didn't put it in parentheses yet. It did it. So I'm going to write down 1.2272. 4 decimals. This is square inches. Okay. Then we're going to find the area of the inner ring. So pi times 0.25 squared. 0.1964 square inches. That's very, very small. The difference between them is subtracting these two amounts. So 1.2272 minus 0.1964. And if I just use the yellow calculator, that's up, 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 enter, minus, up, enter. So it's the outer area that we calculated in the top minus the inner area on the bottom. And when I subtract them, I get an area of 1.0308 square inches. Our total area of the dartboard hasn't changed. It's still 247.45 square inches. So if I want to find the probability of landing in the outer but not the inner, I'm going to use the difference divided by the total. 1.0308 divided by 247.45. And I think this is a reason for me not to actually delete all of that previous work, but I'm going to leave it for now because I have at least the estimate, 247.45. 0.00416. Extremely unlikely. And I know my face is over it, so let me move my cam out of the way. There we go. That's a probability. It doesn't help if it's written like this. Percentages are nice. So I'm going to go over here. Sorry about that. Here we go. Times 100. 0.417%. In other words, really, really unlikely that you're going to land in the outer circuit. You're gonna what is it when you land at a green? What it's called. Okay, sorry. Probability of landing within the inner ring of the bullseye. So the area of the inner ring of the bullseye, we've already calculated that. 0.1964 square inches. That's SQ and IN, square inches. The area of the dartboard, 247.45 square inches. And then last of all, the probability of landing in the inner ring, like the bullseye of the bullseye, is 0.1964 divided by 247.45. Now I realize right now I'm going to need to go back to that calculation because if I'm using as many decimals as possible, I want to use all of 0.19635 and beyond. There's a lot of decimals in there that I want to use. And the same thing is true of the 247.45. So I need to go back and recalculate that just to make sure I'm not rounding in the middle of the problem, and that rounding in the middle of the problem is causing me to make some sort of error. So I'm going to go back and say the diameter, 17.75 divided by 2. This quantity is squared, and then multiply by pi. So if I go up to that number, there's a lot more than what I was giving it credit for. 44.95.088.5541. So I shouldn't actually really be using the approximate truncated decimal amount. I should use all of this. Let's make that go away. Okay, so this is the Cheez-It method of never deleting anything on the yellow calculator. I know somewhere up here is my 0.1964. And then somewhere up here is my area of the entire circle of the dartboard. And by just going up and enter, divide by, enter, it gives me the actual value with as many decimal places as I need, being very careful that I'm doing the right math and not rounding in the middle of the problem. 0.000793. It doesn't help that that's not a percentage, so times by, let's go down to there, times by 100 to make this become a percentage calculation, 0.0793%. It's extremely unlikely that just chucking darts at a dartboard, you're going to land in the bullseye unless you have skill. Okay. What about the probability of getting a triple 20? Let's look at where that is. So a triple 20 is in this, see the triple score section? So the triple score section, this is anything in the black or white or whatever this lighter color is, dark and light. This is a single point score. So a 20, you'd get 20 points. And the inside, land in here, a 20, you would get 20 points, or 5, or 12, or 9, or 14. But if you land in the double ring, you get double that number, so 9 plus 9. If you land in the inner green-red circle, that's triple score. So if we want to be in this little section right here, it looks an awful lot like a rectangle. It's not. It's a section of a wedge. When you look at an orange peel and you've cut it off of the things, it has kind of like a taper, like a trapezoid on either side. But we're going to simplify our thinking, and we're going to say that it is literally just based on height. It's easy enough that way. We're going to round it. We're talking about such a small number of inches anyway, that it's 0.35 inches tall, and we have across this diameter right here. We have the triple score section is 1.26 inches wide. So we're just gonna multiply those two numbers together. That's all that's happening. The height times the width. And the height and the width came from this this height and this width, if you can see my cursor on the picture. So let's do the calculation. 0.35 times 1.26. Why don't you actually pause the video and you go do that calculation and you write it down. And don't let me tell you that because you're smart enough to handle that part. Go get that number. And also get the area of the dartboard. We've already used that number. Go back and use it. It should be in your yellow calculator already. In fact, why don't you just go calculate the probability of getting a triple 20? You're capable. You've seen how to do it 2 other times, if not the previous video. You've got this. I'll answer it, but you should pause the video and skip to the end, okay? Okay, so I'm doing this. I'm going to do the math now. Not a lot of talking out loud. We have 0.35 times 1.26. So that's the area of the triple score 20 section, 0.441 square inches. The area of the dartboard is still 247.45 square inches. So if I divide 0.441 by 247.45, I'm going to get the actual decimal amount. So cheese it, divide by, there, cheese it, 0.001782, which as a percentage is 0.178%. We're approximately 18, right? 0.18%. Thank you for watching this video. This has been a continuation of our conversation on geometric probability, where some really, I would say, annoying calculations. We are using decimals like crazy in this lesson. You've got this. You have access to the calculator. That'll help you keep your decimals organized. And that yellow calculator can be a game changer in your ability to make these calculations faster, quicker, save you some thinking. Know how to use it. Stick around for more information and more knowledge. Up next is page 903. Thank you for watching. I'll see you in the next episode.